principle. So it's a good read, and then he goes on later to show where this algorithm is used as well. And the idea is actually pretty simple. You take a pattern of a specific length. So for example, you take a pattern of 8 steps, for example, 16th notes. And you take a number of pulses, k, which is smaller than n, and you distribute these pulses over the pattern so that it's the most regular kind of way. So for example, you could take 3 hits and distribute it over 8 pulses, and it's going to give a pattern which sounds like this. So it sounds like all kind of dancehall music. I'm just going to program it in here, and you'll see what I mean. So it sounds like... so it's some kind of... I'm going to put it on the bass drum, and then you'll start to recognize it. So that's just 3/8, for example. And if you go into more complicated rhythms, for example, distributing 4 pulses over 9, it's going to give you this pattern. And it always sounds like kind of familiar, because even if it's like a 9-step long pattern, which we're not really used to here in Germany, you would be if you lived in Bulgaria, for example. But it sounds really natural because it's almost regular, and then at the end it just has 1 step more. So you can use these mathematically generated patterns to actually program some really kind of nice flowing rhythms, because most of what I discovered is funky, for me at least, is based on this kind of regular distribution. So a lot of the music I do is based on that kind of idea. So it's really cool to have a way to actually try them out just by inputting 2 numbers. And actually, if you read the papers, I think like on 10 pages he goes through every K and N variation and lists all the traditional rhythms, and like this one is used in rock and roll, and this one is used in Cuban music, and this one is in Africa and Nigeria. And it's really interesting to read it and then to look up the ideas. So my idea was to build a sequencer where each track is actually just generated using K, N, and an offset. So you can start at different points in the rhythmic pattern. And the implementation of that algorithm is very easy. In the paper, you have a way to calculate it by hand. But if you actually program it on a computer, the simplest way to distribute these K pulses over N is just to divide N by K and then count it up. So the algorithm itself just looks like this. You have a pattern with 32 bits, for example. For the longest one is 32. And then you just go increment that counter and then set the bit if it just overflows. So that's written in fixed point arithmetics because it's on the microcontroller. But it's really simple. It doesn't need a lot of CPU time, and there's good fun with it. So I built this 4-track synthesizer using the tempo synchronization on my board, so it's really tight when you use an external sequencer. You can generate the tempo internally as well, and then use a knob to set the BPMs, for example. And all I do is on every 16th callback, I'm going to use Euclidean rhythm tracks, check if that track is being hit, and if that's the case, I'm just going to trigger a track on the machine drum. So I haven't actually took the board with that software with me, but if you come tomorrow, I'll be able to show you, and there's some really cool rhythms and polyrhythms hidden in it. Yeah, and it's an amazing way to try out these kind of polyrhythms before trying to work them out by hand. And you can focus on a few and try out all kind of variations just by turning the knobs. So it's really nice to get into the flow and use that. But one way I extended that idea was to use the algorithm to generate the rhythmic pattern of a bass line. So most bass lines, I think it's easier to think of them as a percussive pattern, which maybe has a few notes in it, but mostly it's just percussion. So what I use is to use the Euclidean algorithm to generate the rhythmic pattern of the bass line, and then use an arpeggiator, which is just like a cycle of loops, to put some pitches on it. So if you take a few pitches and play them on every hit, if the length of that pitch pattern is longer than the rhythmic pattern, it's going to swirl around and make some kind of polyrhythm on the pitch level. And it's actually a really nice way to come up with disco bass lines and that kind of stuff. And still using the Euclidean algorithm, the pulse is going to be quite regular. And so if it's slightly off, it's going to sound really syncopated and stuff. So I'm going to demo you that firmware here. So I just have to plug in a few devices. And it's this board here. So the way the sketch works is it's produced on 3 levels. The rhythm information is produced by an Euclidean track, which just generates the rhythmic information, like the one I showed you before. So you just input K and the offset. And the notes are produced randomly, but are stored in a cycle. So you can press a button and come up with some new notes. And then finally, these notes are transformed into the machine drum pitch. And it turns the machine drum into some kind of weird, bassline synthesizer weird thing. So I think I have a pattern here, which is just a bass drum. So just to show you some basic pulse information. And what I'm going to do now on the 16 callback is just have this area here where I store the pitches and just loop around that area. So if you know C, this is just a way to increment a circular buffer. And that's the callback function I get from my synchronization stack on every 16th note. So let's try it out and I hope it works. So here the notes, this one is the baseline I'm using to produce the pitch information. So that's the same if you use it on the machine drum, it's going to have all these kind of weird pitches, and it's transformed by the MIDI Arduino. So that's some kind of regular pattern, and I'm just going to randomize the notes on this one. So it sounds quite stupid, but if I start to change the pitch, the rhythmic track, for example, just put 3 hits in 8 pulses, it's going to sound like this. Which already sounds way cooler, I think. And then if you start to randomize it using, for example, just 2 notes, it's going to... I can go up to 3 notes. Go over to 4 notes, for example, and then start to go into polyrhythms where the rhythmic track is going to wrap around the bass drum, so it sounds like this, for example. So that's 7 against 8, or 7 against 4 if you want. And you can go into way more complicated stuff. And then just start to add the prototypical techno stuff into it, which would sound like this. And have fun with it. So. And just, I don't know, have fun with it. So it's really interesting to come up with these ideas for this. Thank you. So that's really one I've been using a lot yesterday. We made a few tracks with it because it's just really nice to actually, reduce yourself to just 2 notes and then start exploring rhythmic possibilities with that, for example. And as I said, I'm going to show you that later if there's some time left. But another thing I've been doing is I bought a CNC mill not long ago. I've talked about everybody that knows me just knows like CNC milling. I actually bought it to do casings for my MIDI controllers, so to mill them out of aluminum. But I was starting to look into the stuff you can do with the CNC milling application. It's just like a whole crazy world, and there's going to be Breeze talk later on, which is just about that. And one thing I've been doing for Christmas is I've been thinking about doing to mill LED lamps out of wood, so just have some kind of really simple frame and then mill some openings in the side which are going to be generated using algorithms and look really cool, you know, have some kind of phase effects and all the stuff you wouldn't really want to mill by hand, but which a computer you can do really well. So I haven't actually finished those lamps before Christmas, but I'm going to show you the design application of rodent processing to just come up with some kind of cool ideas. So I use processing to generate some kind of 3D scene and then convert that 3D scene to DXF and then import it into the milling application. And what I do is control the design parameters with the MIDI controller rather than with the mouse, for example. So if you use the mouse, you would have to, you know, input some kind of control surface and processing. It's all pretty annoying to do. So I just hook up the MIDI controller and say, okay, the first parameter is going to be, you know, the number of circles, and the second one is going to be the width of the circles. And I think oh, there's some, you don't need to see that. I'm just going to open processing and show you the application. Oh, that's Arduino, sorry. They look so similar, I'm always confused. So that's processing, that's the code to generate my lamp. And you can see here I use my library to open the MIDI device and then just get some CCs out of the controller. So I'm going to start that one and hope USB MIDI is not broken today. So that's the kind of ideas I had for the LED lamp, to just have the side of the lamp with these kind of attractor patterns, and you know, there's going to be some pulsing LEDs inside and it's going to look really, really cool. And every side is going to be different with some different attractors, or you can use lines and have some kind of line attraction, which looks really cool as well. And normally if I just use the controller here, I should be able to change the parameter. So it's pretty interesting to just turn knobs here and see how it's going to look. And you know, just press randomize. And I think one of the things I've been doing is hook up a sequencer to that. So it should, you know, I can just, so I think that's like 80 BPM or so, and it's going to change on every 16th note. So you can use it for techno visuals or so. But it's actually really fun to know, you just like try out how is it going to look like this, or maybe I need a lot more, or maybe less. And if you start to go into weird zones, it's going to look like this, which is pretty cool as well, but I don't know, that's a bug or so. But actually the cool thing about it is that you're going to input some parameters you haven't thought of before, and the most important thing is I think you can change 2 parameters at once and just see how it interacts. And if you just have the mouse, you'd have to use some kind of, not a knob, not a slider, but some kind of other input device. So here you can just go and, you know, change it like this. So that's one of the cool things you can use MIDI for as well, is just use it as a GUI for a lot of applications. And I think 2 years ago we built a laser controller, you know, with galvanometers and controlling the mirrors. And I was, you know, I don't like GUI programming, I like embedded programming, so the control software for the laser was just the MIDI controller. And you could, you know, change the animations and stuff. And it's much easier than writing a whole GUI, you know, with GUI callbacks and widgets and all kind of weird stuff I don't understand. So let's switch back to Keynote. So yes, that's, I milled circles of different radii, I think, or radiuses, radii, I don't know. Using attractors to create attraction zones, and you can actually apply that kind of thinking to every kind of graphical algorithm. Sorry, radii, okay, so different radii, or you can use lines, or for example, if you take one shape, for example, triangle, and then just start to morph the triangle over the whole design, which is something you'd never be able to mill that precision by hand, but it just looks really cool when it's just like perfectly phasing around the lamp, and then you have an LED inside that goes. Yes, I just use my MIDI library to control the parameters, and here I have this callback on controller change, and you know, there's some kind of weird ideas you can apply to that, which is like tempo synchronization, or you can use it easily to hook up a MIDI controller to control visuals.